Well, this is the last talk of the day, right? So 5:50 till 6:30. Please hang with us. We appreciate you making it, right? So, and of course, we were talking about, how margaritas would have filled up the room, but yes. But that being said, so I'm Vamshi, and this is Brian, my colleague. We are from MD Anderson in Houston. So we're going to start off with just to understand the attendees' profile, how many of you are from the healthcare industry? How many of you have heard of MD Anderson before? Oh, that's awesome, right? So not to be duplicative, but we have a few slides that introduce where we're coming from when we start talking about this. And then we'll get into some of the details. So let me press forward. So this is the agenda. So we have a few minutes to talk about MD Anderson, and then we'll walk through the big data program as we have it at this point, and get into some details about our Hadoop implementation. And along with that, every implementation has lessons learned, good lessons and some not so good. So we'll try and walk through all of that with next steps. So when we were asked about coming here and talking, Brian and I, we were discussing, and we said, okay, we just started our journey, right? So the thought was, okay, let's start with this quote. We've seen this before, we've heard it before, but essentially the short gist of it is a journey of 1,000 miles begins with one step. And that's where we are, maybe one step, 1.5, we'll see. But at least we're getting started. So about MD Anderson. So just to give you an overview, so we are a state institution, state of Texas legislature created MD Anderson in 1941. It is the one of the world's largest centers devoted exclusively to cancer care. Of course, and we've been named one of the top 2 cancer hospitals in the U.S. News Survey since 1990. Since that's when the ratings have been provided, and since then we've been in either number 1 or number 2. That being said, our mission, essentially it's a simple one, like our president says, Dr. DePino says, our mission is to eliminate cancer, first in Texas, along with that in the nation and the world. And we focus on this in 3-pronged approach: patient care, research, prevention, and education. So I'll go into a little more on, okay. All right. So about MD Anderson, patient care, just want to give you a few stats. And please keep in mind as you read through this is all cancer. And cancer-related treatments. All these stats out there. So, and a few things, I don't want to go through every detail, but I'll point out a few. Outpatient, 1.4 million outpatient procedures each year at MD Anderson. And these days, if you know what an outpatient procedure, and we've been through, some of us have been through with loved ones, etc. Chemotherapy, radiation therapy, proton therapy, you go through surgical procedures. They're called outpatient these days, but it takes a long time to recover, right? So not to trivialize that number. And it's 1.4 million procedures like that happen at MD Anderson each year. The one other thing I want to point out is the number of clinical research protocols. There's a lot of numbers up there. I'm focusing only on 2. More than 1,100, last count, almost 1,200. All these 1,200, almost 1,200, are focused on cancer research only. Various types of cancer, various types of ways of treating, avoiding, preventing, and actually mitigating, eliminating cancer, as we say it. So just to give you an idea of our education profile, again, lots of stats. This was only 1 year. We had a total of 6,600 folks being trained in various treatments at MD Anderson. Now, nursing, schools, clinical researchers, etc., but the total for 1 year. And lastly, research. This is one of the cornerstones of what MD Anderson does, along with patient care, of course. But if you look at the stats from FY11, which is our fiscal year, let's say 2011, to fiscal year 2015, our investment in cancer research has gone up 25%. And as you see from these numbers, the federal grants have gone down, but a lot of the new source of funds is coming from the private industry. As you see, it's gone up, also from philanthropic funds, private donors, and a lot of resources from MD Anderson's direct patient care activities. Whatever MD Anderson makes from taking care of patients gets turned around and invested right back into it, as those numbers directly show. And the non-trivial number is $780 million in cancer research from MD Anderson in fiscal year 15. This includes, of course, not just IT budget, of course, everything that research encompasses, right? So one more, and then we'll get into some of the big data program. So in yes?
Sorry, wasn't quite easy to hear you. You may have to do a sound check.
Are you able to hear me? No? Now? Thank you. Oh, absolutely. I certainly didn't want to drown people out, so I could speak. Thank you. So 2012, MD Anderson launched what's referred to as the Moonshots program. Now, this is different from the federally launched Moonshots program that's more recently in the news. But in 2012, our president, Dr. DePino, launched Moonshots program to eliminate 12 different types of cancer. Essentially, the goal is to make a giant leap and take care of all these items that are being called out here. So specifically targeting these 12 different types of cancer. I'm not going to go through the list, but the goal is to put in place transdisciplinary team science approach. And no, that's not a typo. It is actually the right word. We had a few questions about that. But the essential context here is to accelerate the pace of discovery and turn it around into clinical care and reduce cancer impact. And one of the ways we can do this is through transformative professional platforms, and that's where big data fits in.
Yep. Good afternoon, everybody. So I'm going to talk a little bit about our journey. Can everybody hear me in the back? Good. Okay, so we don't have a lot of time today, and there's a lot of things that we're working on around big data. One of them is around our Hadoop distribution and our Hadoop implementation that we have recently embarked on. Vamshi mentioned that it is a journey. We are beginning our journey. I would say, though, even though we're beginning our Hadoop journey, our big data journey might be a little bit further along the way, just because there's many pieces to that, and we have been doing some things along the way. And when we define big data, I think traditionally, a lot of people talk about the volume of data and the variety of data and velocity of data and veracity of data. And so, as you guys know, being in the healthcare industry, we do have a lot of different types of data. We have patients, like Vamshi mentioned, back to 1941. And in a hospital, not all of the data is always structured. We have a lot of unstructured data, like transcribed documents, pathology reports, and ultimately what we're trying to do is pull information out of that so that we can actually lead to a discovery of cancer, hopefully in the future. The analogy that I like to use is the Gulf of Mexico. We are from Houston, so we're very familiar with the Gulf of Mexico in Texas. But does anybody know what's underneath the Gulf of Mexico? I'll ask a quick question. Oil, yeah, oil is under there, right? And only until recently, probably the last few decades, where petroleum industry, the petroleum industry and oil companies learned to build platforms and drill in the deep sea, extract the oil, transport it, take it to a refinery, refine it, and convert it into gasoline and make energy. That's when we really got the value of the assets that are underneath the Gulf of Mexico. I love this analogy because we have data since 1941 over 1.2 million patients and lots of data about those patients, but a lot of it is just dark. We can't get to it, we can't do anything with it, it's unstructured. But our goal is to try to figure out ways to make it available. So some of the goals of our big data platform is, the first one is to become a data-driven organization. And so that is, from the highest senior executives, we are really trying to get there, become an organization where every worker from senior executives to, admins, everybody's using data to make decisions. We want to, another goal is to be able to handle, access, compute, visualize all types of data, whether it's structured, semi-structured, unstructured. We have several ways that we're doing that, which I'm going to talk about in a couple of slides. We want to access it again for clinicians, researchers, administrators, ultimately, hopefully to improve patient care, get some research discoveries, and improve the operations of our business, right? To become more efficient so we can have money to invest in research and then ultimately cure cancer. Second to last is we want to govern this like a data. I have a slide on data governance because we want to govern our data like an asset, and ultimately we want to provide a platform. And so we have some stuff in place right now. We want to make it more robust, matured, and make a good platform so that we can do all of these things. If I were in an elevator and people ask me, what do we do? I always say, we want to provide the right information to the right people at the right time with the right tools. And I point out a couple of things. The data is okay, but unless we transform that data into information, but ultimately into an insight that we derive out of that information, that's the important thing. And the second thing that I always like to point out is, all the way on the right-hand side is that S, the plural. Tools are plural. There's not one thing. People think, oh, there's just one tool that can do everything. But depending on the use case, depending on the user, depending on what we're trying to do, there's different tools for everything. And so ultimately, though, it's to derive those insights. So data turning into information to provide an insight so we can find that research discovery, so we can cure cancer, find that needle in the haystack. Ultimately, it's about what do we do with that data and what do we derive from that data. We like to talk about building everything we do as the foundation. If you look at a heat map of the United States, we don't want to build something once and then the next use case we build it again and then repeat our processes. We want to build a foundation so that we can keep leveraging the data that we've ingested already, leveraging the tools and the processes and the people and the technology that we already have, and continue to mature it. So these are some of the things that we're doing today. I was joking with Vamshi, usually when we present this, like every single one of those bullet items, we spend like an hour or two talking about, but we don't have that kind of time today, so I'm going to fly through these. We will be here afterwards for some questions, but talk about our existing enterprise data warehouse, work we're doing with natural language processing and machine learning, data governance, very important to get that started early. Our Hadoop NoSQL implementation, where we recently started or implemented our Hortonworks distribution of Hadoop. Work we're doing with cognitive computing, data visualization, and then talking about evolving our platforms, continuing to discuss use cases and train people. So I'm going to go through, into each of these a little bit, but not in a lot of detail. So the first one, a lot of companies, and you guys are probably one of these, probably have traditionally relational data warehouses or enterprise data warehouses. So do we. If you look from left to right, we have many different sources feeding into an existing enterprise data repository, which the important part I always tell people on this slide, the stuff on the right is the most important piece. It takes a lot of work to integrate and ingest data. We have over 50 domains that we're ingesting right now into our relational data warehouse. But the important thing is, can we get those researchers, can we get those clinicians, can we get those administrators to use that data, to visualize that data, to access that data so they can derive an insight? So the right part's the most important thing. Ultimately, we want to break down data silos. And when I talk in a second about Hadoop, it's the same thing. We want to break down data silos, and we want to make that data available to people. Natural language processing. So we have a really good natural language processing team, NLP team, that started a few years ago, or we built a few years ago. Every time they help somebody out by making unstructured data structured, everybody's like, I love that. I want more of that. And so every single use case, they think, well, I want some more NLP. And we're like, well, that's not NLP. They're like, that's okay, but I want more of that. And so people don't really understand how it all works, but we're saving a lot of people a lot of time, decreasing the amount of abstraction manual work that we can in our organization by using natural language processing. Some examples at the bottom are, extracting diagnoses and comorbidities and family cancer histories from clinical notes so that people can use that information to derive some more insights. Recently with ICD-10, when we went live last October with ICD-10, we started having record number of the ICD-10 coders were having to do a lot more work to actually derive an ICD-10 code, and we started having record backlogs of coding for ICD-10, and now with NLP, we are at record lows, and so it's really helping a lot of people out. Cognitive computing, we have been doing a lot of work the past 2 years, trying to build some systems of insight using some technology where we can leverage natural language processing, machine learning, but then also use a visualization mechanism where you can provide feedback. So we're doing a lot of that. I love this slide because from left to right, you talk about the data as you mature, starting from our systems of record to systems of reporting, and then ultimately getting to systems of insight. But also from top to bottom, it shows that there's all different types of data, whether it's structured, unstructured, internal, external data that we're trying to bring into this process. Data governance, very important. I heard a lady speak earlier, and she talked about data governance, very important. The sooner you get started, the better. We hired our data governance manager about 2.5 years ago, trying to identify lots of components around data governance, but identifying our data stewards. Where we work, we don't say data owners. I heard a couple people talk about data owners. We shy away from data owners. The Board of Regents of Texas own our data, but we have stewards that manage our data, and we're trying to make all of our glossaries available, our data dictionaries available, our metadata available. We're starting a data quality and data profiling program. We are working with compliance to, and have been working with them to identify policies around when you can access data, who can access data, which roles can access data. And then master data management, very important. This past year, we've done a lot of work, did an RFP, have a tool for master data management. We're starting to master a few tools. So if we build this out, you saw the whole top part of this slide. One of the things that we have done, I mentioned earlier, implemented Hadoop, our data lake. And basically what we're doing is we're trying to figure out how it fits all together, right? And so we have these existing assets on the top. We want to do more with unstructured data and all types of data so that we can compute, access, ingest, and visualize all types of data. So we're starting our journey, which Vamshi is going to talk about, around our data lake. And so we can derive more insights with more types of data, both internally and externally. If we peeled back the cover on this, it's this next slide. There's a lot of things, and we're going to talk a little bit about this in a second, but there's a lot of things in big data. It's not just one thing. It's not just the people. It's not just our existing repository, but there's a lot of components which we're going to talk about, a lot of things that you have to put in place, and a lot of things that we're trying to mature to get to our goals.
Yeah, absolutely. So let me get into a little bit of detail on our Hadoop implementation. So we started working with Hadoop last year, early spring of 2015. And at that time we had a few requests from our researchers who had some experiments they wanted to run on the Hadoop platform. And we said, okay, we can make that happen for you. We have various competencies in our IS division. So the high performance computing team started down that path, and we stood up the Apache distro. And we took that and we validated a few use cases on it. And after we demonstrated the usefulness in the pilot program, our institution was ready to invest in this program from an enterprise perspective. And that's when Brian and team, we all worked together to find a partner. And of course, you know who the partner is. We're at the summit. And yes, absolutely, it has been a great partnership. And I see Scott here, of course, and Vedant, who directly, so I want to call out these two folks from Hortonworks who've been very useful in our implementation. So what we did earlier, and this is the implementation that we put in place as of February. So after we did our pilot on the Apache distro, then we moved on, and when we started engaging for our HDP platform, we said, all right, let's leave the dev cluster alone, and we're going to start out with the test and then a production installs. And this is what our test cluster looks like. That was in February, and we have. We'll talk about future plans later, but you'll see it is a small startup cluster. There's a lot of overlapping components, a lot of components installed on single nodes, but essentially it's a test cluster. So as far as the use cases and usage of the utilization of those nodes define and determine it, we can expand and add more as needed. But with this and then the production cluster, so it is about 10 nodes right now with 4 data nodes, 2 primary and a failover name node, and then the 4 different nodes for our masters and a failover on the masters too. So when we stood this up, essentially this gave us, and I'll have some more details in the next couple of slides, but this essentially gave us about a 28T net usable space, 28 terabytes of net use on local storage for those 4 nodes. This is accounting for, of course, some system space, and after that, some leftover space for performance reasons, so that whatever is there, we don't want to use all of it anyway. We try to stay under 80% utilization on our clusters from a storage perspective. But this is our implementation, and I'll get into the future plans later on. But if you're wondering about the name, it says Helios up there. So the previous one was called Hornet. So we have a way of naming our clusters, which comes from the high-performance computing world, that we have various clusters for that too. But essentially, we follow naval warships, aircraft carriers, submarines, and this tells you, right? So we have some folks who've actually been in those submarines, and that influence and that culture comes into the team. And we just thrive at and have some fun too with the names. Our users like it too. They don't want to call everything an NGS cluster and a Hadoop cluster, and Hadoop 1 and Hadoop 4. It doesn't really work. So it takes some time to get used to these names, but we've had some success and user participation in those names. So they actually like it when we start talking about them. Some simple stuff, but this increases your user engagement. So, let me, I'm torn whether I should jump forward one slide or stay on this, but let me actually continue as it's set up. So when we went into production in March, early March, we started ingesting streaming data from our bedside, from a bedside sensor data for vital signs. So we have about 300 sensor machines that are, earlier if you noticed some of the stats, MD Anderson has about 665 inpatient beds. So out of those 665, we currently have about 300 bedside sensors that are streaming data into our cluster today. When we went live, so these are those numbers, right? About 1.5 million messages per day. Estimated storage use is about 5.7 gigs. So the number of channels, and I'll get into some of the details on why those channels are important. But currently we're at 24. And processing capacity daily is about 4.3 million. Now, why do we need 4.3 million? Well, what if we went up to all those 663 beds? But we'll talk into some of those. So you'll see this slide. So the red line at the bottom talks about our messages processed. And the blue line talks to our ingestion. Now, what is the distinction? So when we went live, our production implementation has a listener. We listen to the messages that are coming in, and we save off the raw message. That's the ingestion part. And after the message is saved off, we want to do some logical parsing, transformation of the data, and put it into HBase in a logical manner. So the raw messages go into HDFS, the transformed part of the message goes into HBase. Now, you'll see that the red line is very low compared to the blue. Our primary objective there was to have a stable cluster because at the time we went live with this, we also went live at MD Anderson with our EHR system. With most of you being familiar with healthcare, with the change that the EHR system implied for the processes and the clinical set, we wanted to ensure that the Hadoop cluster is not going to be an issue. Our ingestion could be successful. Our processing could catch up at a later date. There was really no rush to cause any production issues on this. We have enough to do on the EHR implementation side. So with this implementation, what I can give you some numbers. We were able to do is essentially scale up our channels. And I said, number of channels currently being used, 24. We started with 1 channel for processing those messages. We were ingesting 1.5 million plus, and we were processing about 180,000 per day. Yes?
Just to confirm, are you talking about HL7?
Yes, these are HL7. Yes, yes, agree. And you'll see those spikes happen. I can't see the dates here, but let's say 325, you see it starting to spike up. That was when we went from number 1 channel to 4 channels. And then again on 4.8 or 4.1, we went from 4 to 6. And then on 4.8, we went from 8 to 12. And eventually on 4.15, 4.14 actually, we went from 12 to 24. And even at 24 channels, processing 1.5 million, I'm glad to report that the server utilization on the nodes has not crossed around 30% utilization. So we still have a long ways to go from utilization and capacity perspective. If you thought when you looked at the production cluster that it was kind of small, yes, it is small. You know, on our HPC clusters, we have 8,000 cores on one of our basic cluster. I mean, this is about, really, the data nodes are around, 4 into 12, which is 48 cores. So where's 8,000, where's 48? But that being said, 48 obviously has a lot of power too. Let's not underestimate it, right? So sometimes you just need to go through the process and figure out what exactly works and how much it takes. That's what gets the institution's buy-in, if that's what you're looking to understand, is just start going through the process. Now, one more step. So the blue there is our storage capacity. Because when we went live, there was a huge concern. How much capacity do you have? How long will this stay up? How much are you going to use up? Well, the red, it doesn't register to an extent. And that's the point of it, right? So 5.5 gigabytes per day translates to around 12.5 terabytes over 6 years. So we have a long ways to go. Even if we scale up to 660 bedside monitors, we still have a long ways to go. We're very comfortable with where we are at. We have things to do, of course. We have to improve. We have to continually invest and grow the platform. But so far, this is where we're at, and it's going very well. Now, this is our architectural diagram. I was torn between whether this should come first or those numbers, but essentially, I want to focus on various verticals, from the data source to where the data is being captured, and then we have the integration engine, from which data goes to our EHR system, which is Epic, depicted on the bottom, and then message validations occur. So there's a validated message, and then there's a raw message. Both of these come in to the platform, and the raw message is stored as is. The validated message is actually transformed into HBase. In the future, the MDA big data and then the access portals are where we would like to be, and we are already on our way, but not in production yet. So I don't want to jump the gun. Maybe we'll have more details when we get to that point. Going into one other slide. So one of the things that we have found very useful as we approached it is, so who here is new to software development? That's awesome.
Nobody.
So today, in a non-Hadoop environment, what do? We have dev environment, test environment, production. We have automated builds. We have test processes in place. Nothing gets into production without a change control or some form of change control, however your organization defines it. There's no reason to do anything different from our perspective. Again, I can't speak for everybody, but from our perspective, there's no reason to do anything differently. You still need a dev cluster, a test cluster, and a production cluster. Nobody needs admin access, write access, etc. in the production environment. We need read-only access, and then we need service accounts. After that, everything else is kept clean. We move it into the test, and we're actually into the dev cluster. So this essentially is a depiction of what we do of our software from our software development frameworks. This is what we will be doing for Hadoop as well. We did a part of this when we went live in March. We didn't have our dev cluster there. That's why I'm calling it out as part of it. But essentially, this is what we are going to pursue as we go into next steps. So we'll get into lessons learned and focus on what went well. Yeah.
So I'll start with a couple of lessons learned. So at the beginning, so it is complex. It's not something simple. I tell people it's not something you can order on Amazon or download from the Apple Store. It's complex. It's the second thing. It's a journey. We started out. This is a journey. We're at the beginning of our journey with this Hadoop. We're maybe a little farther along in our big data journey, but it is a journey. It's not going to be something we implement in a month or 6 months or a year, and it's going to just continue to grow and mature. The industry is changing as well, so it's always a journey. Leverage existing strengths. I think what we're trying to do anyway is leverage the people, the processes, and the tools that we have in place. Train people with new skills, leverage some of the existing things, and try to fit in some of these new technologies, maybe eventually transform into something else. And processes. We're putting in more processes, but we're leveraging the processes that we have, especially around data governance and accessing, so that we can do the same thing for the Hadoop data.
Yes, and then as we look at collaboration, I mean, we all have various boundaries in our institutions or organizations, etc. But every area and the skill set could be dispersed. It's about trust in each other. It's about bringing together right people across matrixed organizations. And some of us in very conservative organizations may feel that matrix form of teams, et cetera, doesn't work. It's not the case. It's actually the commitment to the mission. Whatever your company does, whatever your commitment to the patient, in our case, essentially bring together the right people for the right role and the right purpose. And that's what it is about. Sometimes this collaboration turns out to be the elephant in the room that stops a lot of projects from proceeding forward. It doesn't have to be that way. It has to be all on the table. Part of trust is a key component in what you need to make things happen. Otherwise, the big data programs, in some cases, Hadoop effort is built off in such a silo that we can question the effectiveness of it. But again, learn from experts. So when we stood up our Apache distro, I'm proud to say the team went and learned, read online resources, and stood up our cluster. We validated it. We successfully piloted it. Would it have been easier if we had a partner at that time? I would say yes. but we were not shy from learning just by ourselves. I mean, we are already technical organizations. Most of us are already in there. There are people in there that are motivated. If they're given the opportunity, they will step up. Of course, learning from the experts is always preferred and helps ramp up your time to delivery, etc. So that's one thing we learned. The other thing we look at is one cluster, multiple use cases. Essentially, when we say that, of course, you might just say, I just saw you show us 3 clusters. That's not what I mean. I mean one production cluster, dev, test, production. But one production cluster with right tools configured so that we can run next-gen sequencing jobs, we can stream data from Capsule, we can actually run, and I'm getting into some other use cases. But there's so many things that you can do, but have one cluster with the right governance, right security structure in place, and with the right processes. And when I say follow best practices, I would refer us back to the previous flow that we saw. You know, one of the processes for code or bits to be migrated from environment to environment. Follow the best practices. It doesn't, just because we are starting down our journey, doesn't mean we have to do it in a haphazard manner. We can experiment all we want on the test environments, dev environment actually, and then by the time we get to production, we're production ready. It's as good as other production apps. It doesn't have to be any different. That's what our opinion is anyways. But again, the 3 components there, people, process, technology, I mean, they're key to, they're the cornerstone of everything. And I want to expand a little bit more on the continuing to expand and evolve our platform. Now, in our next phase, we want to add in governance, add in security, and expand our cluster from a dev, from a test, and test environment. And in some cases, I don't know how many of you might disagree, but we will disagree after we finish this and during the questions session. But we are not opposed to using virtual machines in the clusters in a test environment. Dev and test, depending on the workloads, VMs are super powerful these days. Our implementation of VMs, we actually have very high throughput compute jobs, very high throughput analytic requirements with 50 terabytes of storage on a VM. So there's a lot there, but of course, some of us might be more comfortable having physical machines. However you do it, our plan is to, from our perspective, is to continue to evolve our platform, invest where appropriate, and in the right manner.
Yeah, and some of the next steps are, number 2 says ingest more data, but I think really the better would be have access to more data, whether it's in our Hadoop cluster or however we do it, but really getting people access to more data and then identifying more use cases. We actually have a huge backlog of use cases, and we're trying to prioritize them and more use cases come in. So we're trying to figure out a way of, we get NLP use cases and cognitive use cases and big data use cases and typical data reporting use cases, and we're trying to figure out how do we integrate all of those, and then perform the right analytics and use the right tools for the right use case. And then,
yes, and then finally, not the least important for sure, is to develop and train people with new skills. I'm actually proud to report that as far as the Hadoop cluster and administration and all to the point of ingesting the initial data from Capsule, we had no net new hires. It was essentially all done in-house with existing resources. We had, from a high-performance computing side, we have people who are very proficient in administering large clusters. This is new technology, but it is still a cluster. They're actually, like I was saying, 8,000 core cluster. Another one is a 2,400 core cluster. So yes, they needed to learn new skills, but they have the right aptitude and the right attitude to go into it and approach things that way. So we've actually been able to leverage our existing people, existing team members and them and continue to invest in them. I mean, we're here, but Oscar in the back, he's from our team. And we have others who are the Spark Summit and some other summits that that we won't maybe get into here. But essentially continue to invest in the folks and in the team members. They will drive what we need to do here. And of course, there are going to be disciplines that need new people, but that's always going to be the case. With that,
Yeah, I think
with
that we are here to take more questions, or you can run off to get your margaritas. But but thank you for having us and being here in San Jose.
yes.
You guys talk a little bit about your administrative support that actually allows this type of stuff to happen, because a lot of times it's kind of like an unfunded mandate. It says, we want to do this, even though we've already given you 90 other things to do. And so how do you work around that? You're one person.
Yes. So the question was around unfunded mandates and administrative support.
Yeah, I think it's a little both. So we are lucky we have people that were doing this with traditional, I always talk about, the BI analytics team have been doing BI analytics team for a long time. We just never call them data scientists. So we were doing that, and it's really a matter of then showing the value of if can we do this with new tools. We did a POC like Vamshi mentioned, and so part of it is like extra work that people were spending to do it, but then part of it is then convincing upper management to give you funding, to give you additional resources when needed, and actually we're going to get some additional people hopefully in this coming fiscal year to be dedicated to this, to expand it. So I think it's a little of both. It's not like they supported us and they gave us all kinds of unlimited money and funds. We did have to, it was like side jobs for some people for a while.
Yes, but we certainly see the value in it.
Yeah.
And really, even the team members are very motivated because they want to, from their career perspective, from their interest perspective, they too want to get into the new field. And they're motivated. It's a matter of channeling their energies and, of course, trying to help them with their existing workload. But again, when you have somebody that's interested and dedicated, they don't view it as an extra task. That's really the key. Yes, sir.
You guys are not using cloud at all, so is that based, and policy is based on the PHI data, or?
Yeah. So the question was, are we using cloud or not? We are not using cloud right now. I think traditionally our organization has been shied away from the cloud historically. We're starting to turn the corner on that, so I think it's more of a cultural thing right now. It is about primarily PHI and security and making sure the privacy of the data, but I think things will keep changing and will keep changing also.
Yes.
Do you have any use cases for like genomics or
Yeah.
data that you're using in the big data?
We do. Actually, not in our. So the question was, do we have any use cases around genomic? And so the answer is yes, but not in our Hadoop cluster today. We do do a lot of work with genomics, and Vamshi being in research, there's a lot of genomic files, different types of files that we are processing. In our enterprise data warehouse, we do load VCF and CNV files, so varying call format and copy number variations, so mutations on a DNA sequence. So, and we're able to combine that. So a good example is that sometimes people or researchers will ask, well, tell me how many patients last year were men between the ages of 50 and 75 that had prostate cancer, that had this surgery or this treatment, and had an EGFR mutation or ATK1 mutation. And we're able to provide that information very quickly because of this asset. In the past, it would have taken years and years and years to, well, not years, but months to find the sources and bring it together to answer that question, but now it can be answered quicker. I think with Hadoop, we'll be able to in addition to VCF and CNV, tie some of the, we call it the pipeline, some of the research pipelines that the teams are also working on for immunotherapy and immunopathology and cytogenetics and other types of data. So, did that answer your question?
Yes, it did. Thank you.
Okay.
There's a
Oh,
question
sorry.
over here.
Your MDM, can you talk about that? What are you using for your master data management?
Yep. So we're using Maestro by Prophecy. So that's the tool that we did an RFP about a year and a half ago, and that was the tool that we selected. We actually have mastered location data. We're working on patient and provider data right now.
That kind of runs outside of Hadoop and you're bringing the data out and back in?
So right now it's outside of Hadoop. Yes, it's in its own schema.
Are you storing the unmastered data and then the master data as well?
We are, yes, actually, yes, we're storing it in the staging area and then the mastered data. And you know, certain things like location, you would have thought, oh, that's easy. Like there's, like, it's just from one or two sources. It ended up being more sources than we imagined, and we have to have a phase 2 because there's some additional sources that we didn't catch the first time around. So, good. Well, thank you very much,
Okay.
guys.
Thank you, guys.